Look up, not at the screen, not at the walls of the room you are sitting in, but up. Imagine the sky above you is not blocked by ceiling or cloud, but open, infinite. It is night. The air is cold, crisp, the kind of cold that bites at the exposed skin of your face and makes you feel vividly alive. The stars are out, not the few dozen you might see from a city street, washed out by the glow of sodium vapor lamps and LED billboards, but the true night sky, the one our ancestors knew, the one that terrified them and guided them in equal measure. It is a dusting of diamond dust on black velvet. It is dense. It is overwhelming. And somewhere in that field of light, there is a point that is slightly brighter than the rest. A point that twinkles with a steady, reassuring rhythm. It is not a planet. It is not a satellite. It is a sun, another sun. That point of light is Alpha Centauri. It is the closest star system to our own. In the grand catalog of the cosmos, it is our next-door neighbor. In the language of astronomy, it is practically touching us. And yet, it is further away than anything the human mind is truly equipped to comprehend. We speak of distance in terms we can walk. We measure our lives in steps, in miles, in the commute to work, in the flight across an ocean. We have mapped the surface of our planet. We have drilled into its crust. We have sailed its deepest trenches. We are masters of the earth. But step off the earth just a little bit, and the mastery vanishes. The scales change. The rules change. The distance to Alpha Centauri is not just a number. It is a wall. It is a void so vast, so empty, so hostile that it mocks our ambition. It is a challenge that sits at the edge of our capability, staring back at us, daring us to try. We want to go there. The desire is primal. It is written into our DNA. We are a species of movers. We walked out of Africa. We crossed the ice bridges to the Americas. We built boats to cross the Pacific. We climbed into metal, tubes, and punched through the atmosphere to stand on the moon. We cannot stop moving. The horizon is not a boundary. It is an invitation. But Alpha Centauri is not like the moon. It is not like Mars. It is not even like the edge of the solar system. It is interstellar space. It is the deep dark between the islands of fire. To go there is to leave the cradle forever. It is to admit that Earth is not enough. It is to accept that the journey will take longer than a human life. It is to confront the terrifying reality of physics, of time, of biology, and of the sheer, crushing weight of the vacuum. This video is not a celebration of what we can do. It is an examination of what we cannot. It is a journey into the impossible. We are going to talk about the distance, not just the number, but the feeling of it. We are going to talk about the machines we would need to build to cross it. We are going to talk about the bodies we would need to sustain, the minds we would need to protect, and the societies we would need to create to survive the trip. We are going to look at the technologies that exist only on paper, the theories that hover on the edge of plausibility, and the dreams that keep engineers awake at night. We are going to simulate the journey. We are going to feel the acceleration. We are going to feel the isolation. We are going to feel the fear, because make no mistake, this is a terrifying prospect. It is not an adventure in the way we tell stories about adventure. There are no rescue ships. There are no supply drops. There is no turning back. Once you leave for Alpha Centauri, you are committed to the void. You are committed to a timeline that spans generations. You are committed to the possibility that you will die before you see your destination, and your children will die before they see it, and only your grandchildren might wave at a world they cannot touch. This is the cost of the stars. It is paid in time. It is paid in life. And yet, we look up, we look at that point of light, and we wonder, what is there? Is there a planet? Is there life? Is there a future? The questions are easy. The answers require a journey, and the journey is impossible. Or is it? We stand on the precipice of a new age. The telescopes are getting sharper, the engines are getting stronger, the ideas are getting bolder. We are closer than we have ever been. But close is a relative term. In the context of the galaxy, close is still an abyss. To bridge that abyss, we must understand the enemy. The enemy is not aliens. The enemy is not malfunction. The enemy is distance. It is the silent, patient enemy that waits for us to run out of fuel, to run out of food, to run out of hope. It does not fight back. It simply exists. It is the background of reality. And to cross it, we must change the way we think about movement, about energy, about existence itself. This is the story of the impossible journey. This is the story of us trying to leave home. This is the story of Alpha Centauri. Chapter 1: The Illusion of Proximity. To understand the impossibility of the journey, we must first understand the destination. We must strip away the poetry and look at the astrophysics. Alpha Centauri is not a single star. It is a system, a triple star system. This complexity adds layers of danger and intrigue to the voyage. The system is composed of 3 distinct stars bound together by gravity, dancing around a common center of mass. There is Alpha Centauri A, a yellow main sequence star very similar to our own sun. It is slightly larger, slightly brighter, but fundamentally familiar. It is the kind of star that could host Earth-like planets. It is the beacon of hope. Then there is Alpha Centauri B, an orange dwarf star. It is smaller, cooler, dimmer. It orbits A in a long elliptical dance that takes them from relatively close proximity to distances that would swallow our entire solar system. They are binary companions, locked in a gravitational embrace that has lasted for billions of years. And then there is the third, the outlier. Proxima Centauri. It is a red dwarf. It is small, it is faint, it is turbulent. It orbits the binary pair at a great distance, perhaps a quarter of a light year away. For a long time, we did not know if Proxima was gravitationally bound to A and B. Now we know it is. It is the closest of the 3 to us. When we say Alpha Centauri is 4 light years away, we are usually talking about Proxima. 4.24 light years to be precise. That number sounds small. In the catalog of the Milky Way, which contains hundreds of billions of stars spanning 100,000 light years, 4 is nothing. It is a whisper. It is the distance to the corner store. But convert that into kilometers. Convert it into miles. Convert it into seconds of travel time. The numbers become unmanageable. They lose their meaning. They become abstract. 1 light year is the distance light travels in a vacuum in 1 Julian year. Light moves at 300,000 kilometers per second. It circles the Earth 7.5 times in 1 second. It is the universal speed limit. Nothing moves faster. Nothing can move faster. This is the first wall we hit. The speed of light is not just a speed, it is a constraint on causality. It dictates how fast information can travel. It dictates how fast we can move. to go to Alpha Centauri, we cannot exceed this limit. We can only approach it. And even approaching it requires energy densities that dwarf our entire civilization's output. So, we are stuck with sublight speeds. We are stuck with the long way. At 4.24 light years, the distance is approximately 40 trillion kilometers. 40 million kilometers? Write that out. Look at the zeros. They represent emptiness. They represent void. Imagine a car driving on a highway. A fast car? 100 kilometers per hour? Non-stop. No sleep. No fuel stops. Just driving. To reach Alpha Centauri at that speed, it would take 45 million years. The human species has not existed for 45 million years. The dinosaurs had been dead for 20 million years before that car would arrive. This illustrates the scale. But we do not drive cars. We fly rockets. The fastest man-made object ever launched is the Parker Solar Probe. It uses the gravity of Venus to slingshot itself closer to the sun. At its fastest, it moves at nearly 700,000 kilometers per hour. It is a bullet fired from the shoulder of gravity. If we could launch a probe at that speed toward Alpha Centauri, how long would it take? 6,000 years, 6 millennia. Civilization as we know it is only 5,000 years old. We would arrive in a future we cannot predict. The language we speak might not exist. The countries we know might be dust. The technology we use would be archaeology. This is the illusion of proximity. Alpha Centauri is close only in comparison to the rest of the galaxy. Comparison to human capability, it is infinitely far. It is a fortress surrounded by a moat of vacuum. And within that system, what awaits us? We have found planets. Proxima b is a rocky world in the habitable zone of Proxima Centauri. It is Earth-sized. It could have water. It could have life. But Proxima is a red dwarf. Red dwarfs are violent. They flare. They emit bursts of X-rays and ultraviolet radiation that could strip the atmosphere off a planet in millions of years. Proxima b might be an irradiated rock. It might be tidally locked, with one side burning and the other freezing. It might be habitable, but it is not a paradise. It is a challenge. Alpha Centauri A and B might have planets too. We have not found them yet. The glare of the binary pair makes detection difficult, but models suggest stable orbits exist. There could be an Earth twin there, an Earth twin 4 light-years away. The desire to go there is fueled by this possibility. If there is life, we must know. If there is a habitable world, we must secure it. The existential risk of staying on one planet is too high. Asteroids, supervolcanoes, nuclear war, climate collapse. The list of ways humanity can end is long. Becoming a multiplanetary species is insurance. Becoming a multi-star species is immortality. But the insurance policy is expensive. The premium is paid in energy and time. We look at Alpha Centauri and we see a mirror. We see what we could be. We see a second chance. But the mirror is behind glass, thick, unbreakable glass. The distance is the barrier. It is not just space, it is time. To travel there is to travel into the future. If we leave today and arrive in 100 years, we have jumped forward in time relative to those we left behind. If we leave and arrive in 1,000 years, we are ghosts to the people who launched us. This psychological distance is as significant as the physical one. The crew of such a mission would be severed from humanity. They would be sending messages home that take 4 years to arrive. A conversation would take 8 years for a single exchange. By the time they ask a question, the person who answered might be dead. By the time they receive the answer, the world that sent it might have changed. They would be alone, not just alone in the ship, but alone in history. They would be the pioneers of a new branch of the human family tree. This isolation is a key component of the impossibility. It is not just engineering, it is sociology, it is philosophy. Can humans survive that kind of separation? Can a mission maintain its purpose over generations? What happens if the people on Earth forget? What happens if the people on the ship forget why they are going? The destination becomes a myth. The journey becomes the life. We must also consider the environment of the system itself. Interstellar space is not empty. It is filled with the interstellar medium: gas, dust, cosmic rays. At high speeds, a grain of dust hits like a bullet. At relativistic speeds, it hits like a bomb. The ship must be shielded. The shield adds mass. The mass requires more fuel. The fuel requires more mass. The cycle repeats. This is the tyranny of the rocket equation, and we will come to it. But first, we must accept the reality of the target. It is not a welcoming place. It is a hostile environment governed by stars that do not care about us. Proxima's flares could fry electronics. The binary dance of A and B could disrupt planetary orbits. The radiation background is higher than in our solar system. We are not going to a resort. We are going to an outpost on the frontier of survival. The illusion of proximity is dangerous because it makes us think it is easy. It is not. It is the hardest thing we have ever attempted. It requires a level of commitment that nations rarely sustain. The Apollo program lasted a decade. A journey to Alpha Centauri would last centuries. Who funds a century? Who governs a century? Political cycles are 4 years. Economic cycles are 10. Civilizations rise and fall in millennia. To commit to Alpha Centauri is to commit to a stability that human history does not support. We are building a cathedral that we will not see finished. We are planting a tree whose shade we will never sit in. This requires a shift in consciousness. It requires us to value the future over the present. It requires us to act for people who do not exist yet. This is the true distance. The distance between now and then. The distance between us and them. And bridging that distance is the first step of the impossible journey. Chapter 2. The Prison of Physics. Now we must confront the warden of this prison. The warden is Isaac Newton, and his jailer is Konstantin Tsiolkovsky. The laws of motion are absolute. They do not negotiate. They do not offer exceptions. To move forward, you must push something backward. This is the third law: action and reaction. In the atmosphere, you push against the air. In the water, you push against the fluid. In space, there is nothing to push against. You must carry your own push. You must carry the reaction mass. This is the propellant, the fuel, the exhaust. To go fast, you need to throw mass out the back very fast. To go very fast, you need to throw a lot of mass out the back very fast. This relationship is described by the Tsiolkovsky rocket equation. It is a simple formula. Delta V equals exhaust velocity times the natural log of the initial mass divided by the final mass. It looks innocent. It is deceptively simple. But it is the source of all our pain. The equation tells us that the change in velocity is logarithmic with respect to the mass ratio. This means that to double your speed, you do not double your fuel. You exponentially increase it. To add a little bit of speed at the end, you need a massive amount of fuel at the beginning, because that fuel itself has mass. You have to carry the fuel to move the fuel. And you have to carry the fuel to move the fuel that moves the fuel. It is a recursive nightmare. For chemical rockets, the exhaust velocity is limited by the energy density of the chemical bonds. Hydrogen and oxygen burn hot. They expand fast. But there is a limit. The maximum exhaust velocity for chemical propulsion is around 4.5 kilometers per second. This is efficient for leaving Earth. It is efficient for going to Mars. It is utterly useless for going to Alpha Centauri. Let us run the numbers. To reach even 10% of the speed of light, which is 30,000 kilometers per second, using chemical rockets, the mass ratio would be astronomical. It would be a number with more digits than there are atoms in the universe. It is physically impossible. You cannot build a tank that big. You cannot refine that much fuel. The universe does not contain enough hydrogen to fuel a chemical rocket to relativistic speeds. This is the first hard stop. Chemical propulsion is off the table. It is a technology for planetary systems. It is a technology for the cradle. It cannot take us to the stars. We must acknowledge this. Every time we see a rocket launch, we are seeing a technology that is fundamentally incapable of interstellar travel. It is a candle in a hurricane. It is beautiful, but it is weak. So we need higher exhaust velocities. We need more energy per kilogram of propellant. This leads us to energy density. Chemical bonds hold energy in the electron shells. Nuclear bonds hold energy in the nucleus. The difference is a factor of 1,000,000. Fission releases 1,000,000 times more energy than combustion. Fusion releases even more. Antimatter releases the most. This is the ladder we must climb. But climbing the ladder brings new problems. Fission requires heavy elements. Uranium, plutonium. They are rare. They are radioactive. They produce waste. Fusion requires extreme temperatures and pressures. We have not yet mastered sustained fusion on Earth, let alone in a spacecraft engine. Antimatter requires particle accelerators to create, and it annihilates on contact with matter. Storing it is a nightmare. One leak and the ship is gone. But even if we solve the energy problem, we face the problem of momentum. To accelerate a massive ship to high speeds requires immense force. Force equals mass times acceleration. If the ship is heavy, the force must be huge. If the force is huge, the acceleration is high. Humans can only withstand so much G-force. We are soft bags of water and bone. We break under pressure. We can sustain 1 G indefinitely. That is Earth gravity. We can sustain 3 Gs for a short time. Fighter pilots do it. But for a journey of years, we need low acceleration. We need to accelerate slowly to build up speed. This means the engine must run for a long time. It means the fuel must last for a long time. It means the engine must be reliable for decades. Mechanical failure is not an option. There are no service stations in interstellar space. Then there is the problem of deceleration. Getting there is only half the battle. Stopping is the other half. If you fly past Alpha Centauri at 20% of the speed of light, you have a few hours to observe the system before you're gone forever. You are a bullet through the target. To study it, to land, to colonize, you must stop. This requires fuel. You need to carry the fuel to stop, which means you need more fuel to accelerate the fuel you need to stop. The mass ratio squares. It becomes even more prohibitive. This is why many interstellar concepts are flyby missions. They do not stop. They send data back as they rush through. But a flyby is not a journey. It is a glance. We want to live there. We want to stay. This requires a braking mechanism. Magnetic sails, gravitational assists, stellar photons. We need to find a way to stop without carrying the fuel to do it. Otherwise, the ship becomes too heavy to launch. The physics also dictates the thermal load. Engines generate heat. In space, heat does not convect away. There is no air to carry it. There is only radiation. You must radiate heat away as infrared light. This requires large radiators, large surfaces. They are fragile. They add mass. They add drag if you are moving through dust. The ship must be a thermodynamic machine. It must manage energy flow perfectly. Waste heat is the enemy. It cooks the crew. It warps the structure. It degrades the electronics. The closer you get to high speeds, the more energy you pump into the system, the more heat you generate, the harder it is to get rid of. This is a fundamental constraint. You cannot violate the laws of thermodynamics. You cannot create energy. You cannot destroy it. You can only move it. And moving it in a vacuum is hard. We are trapped in a prison of conservation laws. Conservation of momentum, conservation of energy, conservation of mass. These are the bars of the cell. To escape, we must find a loophole, or we must build a key so powerful it breaks the lock. The key is efficiency. We need engines that convert mass to energy with near perfect efficiency. We need ships that are lightweight but strong. We need materials that do not exist yet. We need physics that we are just beginning to understand. The prison is not impenetrable, but it is thick. And every attempt to break out requires a sacrifice. We sacrifice mass for speed. We sacrifice safety for efficiency. We sacrifice the present for the future. The physics does not care about our desires. It only cares about the balance sheet. And currently, the balance sheet says stay home. But we are not known for staying home. We are known for breaking things. We broke the sound barrier. We broke the gravity well. We will break the distance barrier, but we must respect the physics. We cannot wish it away. We must work within it. We must find the optimal path through the constraint space. This is the engineering challenge of the millennium. It is not just building a bigger engine, it is rethinking the concept of propulsion. It is rethinking the concept of the vehicle. Maybe the vehicle is not a ship. Maybe it is a beam. Maybe the vehicle is not solid. Maybe it is light. The physics tells us what is impossible. It does not tell us what is possible. The boundary is where the work begins. And the work is hard. It is frustrating. It is slow. But it is the only way out. The prison of physics is real. But the door is not locked. It is just heavy. And we are building the strength to open it. Chapter 3: The Nuclear Dream. If chemical rockets are the candles, nuclear power is the floodlight. It is the next step up the energy ladder. And for interstellar travel, it is the first plausible step. The concept is not new. In the 1950s and 60s, during the height of the Cold War and the space race, scientists dreamed big. They did not think in terms of satellites. They thought in terms of planets. They thought in terms of stars. Project Orion was one of the most ambitious ideas ever conceived. The premise was simple. Detonate nuclear bombs behind the spacecraft. The explosions would push against a pusher plate. The shock waves would accelerate the ship. It was pulsed propulsion. It was brute force. It was terrifying, and it worked on paper. The calculations showed that a ship powered by nuclear pulse propulsion could reach significant fractions of the speed of light. It could carry massive payloads. It could carry cities. It could carry thousands of people. It was a generation ship engine. Imagine the scale. A ship the size of a skyscraper. A pusher plate kilometers wide. Shock absorbers the size of train cars. Behind it, a stream of atomic bombs, one every few seconds. The rhythm of the engine would be the heartbeat of the vessel. Boom, 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 accelerating steadily, year after year. The crew would live in the front, shielded by the mass of the ship. The radiation from the bombs would be absorbed by the plate. The plasma would be directed backward. It was efficient. It was powerful. It was feasible with technology existing in the 1960s. We could have built it. We chose not to. The Partial Nuclear Test Ban Treaty of 1963 prohibited nuclear explosions in space. The environmental concerns were too high. The risk of launch failure was too catastrophic. If an Orion ship exploded on the pad, it would contaminate the hemisphere. The political will vanished. The dream was shelved. But the physics remains valid. Nuclear pulse propulsion is still one of the few ways to move massive loads at high speeds. It bypasses the rocket equation by using external propulsion. The fuel is not carried inside the engine. It is ejected behind it. This reduces the structural mass. It allows for higher specific impulse. Project Daedalus, a study by the British Interplanetary Society in the 1970s, refined this concept. It proposed a fusion-powered probe, not fission bombs, but fusion pellets. Inertial confinement fusion. Electron beams would compress pellets of deuterium and helium-3. The resulting micro-explosions would drive the ship. Daedalus was designed to reach 12% of the speed of light. It was unmanned. It was a probe. But it showed that fusion was the key. Fusion is the energy source of the stars. It is clean. It is abundant. Helium-3 can be mined from the moon or from gas giants. It is the fuel of the future. However, fusion is elusive. We have been chasing it for 70 years. We can create it, but we cannot sustain it with net energy gain in a compact package. Tokamaks are huge. They require magnetic fields that weigh tons. They require cooling systems that consume megawatts. Putting a tokamak on a ship is difficult. Putting one on a ship that needs to accelerate is harder. The magnetic fields interact with the acceleration. The plasma instabilities are exacerbated by motion. We need a fusion engine that is lightweight. We need a fusion engine that is robust. We need a fusion engine that works without a grid connection. This is the holy grail of propulsion. If we crack fusion, Alpha Centauri becomes reachable. Not easy, but reachable. The travel time drops from millennia to decades. A human lifetime becomes sufficient. You could leave and return. You could see the destination. But there is another nuclear option: fission fragments. Instead of burning fuel to heat a propellant, you use the fission products themselves. When an atom splits, the fragments fly apart at high speeds. They are charged. You can guide them with magnetic fields. You can direct them out the back. This is a fission fragment rocket. It has extremely high exhaust velocity. It does not require a reactor core in the traditional sense. It requires a fuel matrix and a magnetic nozzle. It is elegant. It is efficient. But the thrust is low. It is an ion drive powered by nuclear decay. It would take a long time to accelerate, but in space, time is free. You can accelerate for years. The final speed could be significant. 5% of light speed, maybe 10. This is enough for a robotic mission. It is enough for a probe to send back images within a human lifetime. The nuclear dream is haunted by radiation, not just from the engine, but from the environment. Interstellar space is filled with cosmic rays, high-energy particles accelerated by supernovae. They penetrate shielding, they damage DNA, they cause cancer, they degrade electronics. A nuclear engine adds to this burden. The crew must be shielded. Water is a good shield. Hydrogen-rich materials are good, but mass is the enemy. You cannot carry enough water to stop all radiation. You must accept some dose. You must manage the risk. The crew will age faster. They will have higher cancer rates. They will live shorter lives. This is the cost of the nuclear dream. It is a trade-off. Speed for health, distance for life. The ship becomes a tomb for some, a vessel for others. The ethics are complex. Is it right to send people on a mission that will shorten their lives? Is it right to ask them to accept that risk? And then there is the politics. Nuclear power in space is controversial. Launching radioactive material is risky. Accidents happen. Rockets explode. If a nuclear core falls into the ocean, it is a disaster. If it burns up in the atmosphere, it spreads isotopes. The public perception is negative. The regulatory hurdles are high. This slows down development. It pushes the technology into the shadows. It limits funding. We could have had nuclear ships by now. We do not. We are constrained by fear. Fear of the atom, fear of the accident, fear of the unknown. But the distance to Alpha Centauri is also a fear. It is a fear of stagnation. It is a fear of extinction. We must weigh the risks. The risk of staying is certain. The risk of going is manageable. But managing it requires courage. It requires leadership. It requires a vision that spans beyond the next election cycle. The nuclear dream is not dead. It is sleeping. It waits for the will to wake it. Private companies are looking at nuclear thermal propulsion for Mars. This is a stepping stone. If we master nuclear thermal in the solar system, we can scale it for interstellar. If we master fusion for energy on Earth, we can scale it for propulsion in space. The technology is converging. The need is growing. The climate crisis, the resource crisis, the existential risk, all point to the stars. The nuclear dream is the bridge. It is the only bridge we have right now. It is rough. It is shaky. But it is there. We must walk it. We must refine it. We must make it safe. We must make it real. Because without it, the distance remains impossible. With it, the distance becomes a challenge. And humanity is defined by how it handles challenges. We do not back down. We do not retreat. We build the engine. We light the fuse. We go. Chapter 4, Riding Light, there is a way to escape the mass penalty. There's a way to leave the fuel behind. There's a way to ride the fundamental constant of the universe. Light. Photons have no mass, but they have momentum. When light hits a surface, it pushes. It is a tiny push, imperceptible to us. But in space, over time, it adds up. Solar sails use this pressure. They are large, thin mirrors. They catch the sunlight. They accelerate away from the sun. They do not need fuel. They do not need engines. They just need light. This is propulsion without propellant. It is the ultimate efficiency. But sunlight gets weaker with distance. Inverse square law. By the time you reach the outer solar system, The push is negligible. You cannot ride sunlight to Alpha Centauri. You would stop halfway. But what if the light was not from the sun? What if the light was from us? What if we built a laser array on Earth or in orbit? A phased array of lasers, gigawatts of power, focused on a sail. The beam would push the sail. The sail would accelerate. As long as the beam stays focused, the ship accelerates. You can turn off the laser when the ship reaches speed. The ship coasts. It does not need fuel for the cruise. It does not need fuel to stop if you accept a flyby. This is the breakthrough starshot concept. It is bold. It is radical. It proposes sending gram-scale probes, chips on sails, tiny spacecraft, accelerated to 20% of the speed of light. They would reach Alpha Centauri in 20 years. The laser array would fire for minutes. The probe would travel for decades. It is a separation of energy and mass. The energy stays home. The mass goes away. This solves the rocket equation. You do not carry the energy source. You beam it. But it creates new problems. The sail must be incredibly light. It must be incredibly strong. It must be perfectly reflective. If it absorbs even a fraction of the laser light, it will vaporize. The heat load is immense. Gigawatts focused on a square meter. The material science is beyond us. We need metamaterials. We need nanostructures. We need something that does not exist yet. The sail must be thin enough to accelerate, but thick enough to survive. It must be flat enough to stay stable. If it wrinkles, it tears. If it tilts, it flies off course. The engineering tolerance is microscopic. The margin for error is zero. Then there is the beam itself. Keeping a laser focused over astronomical units is hard. The beam diffracts. It spreads. Over light years, it would spread to the size of a solar system. You lose the pressure. You must correct for this. You must use adaptive optics. You must track the probe perfectly. The probe is moving fast. It is far away. The latency is seconds, minutes. You cannot steer it in real time. It must be autonomous. It must correct its own attitude. It must manage its own trajectory. The chip on the sail must be a computer. It must be a camera. It must be a transmitter. It must be powered. Where does the power come from? The laser? A battery? Radioisotopes? Every gram counts. Every milliwatt matters. Communication is the next barrier. The probe reaches Alpha Centauri. It takes pictures. It measures fields. It sends the data back. To Earth, 4 light years away, with a tiny antenna, with a tiny power source, the signal will be weak. It will be lost in the noise. We need huge receivers on Earth. We need to know exactly where to look. The probe must aim perfectly. A deviation of a fraction of a degree means the signal misses Earth. It goes into the void. The data is lost. The mission fails. The precision required is staggering. It is like hitting a coin on the moon with a laser from Earth. But the coin is moving, and the Earth is moving, and the moon is moving. Everything is moving. The navigation must be perfect. And what about stopping? Starshot is a flyby. The probe rushes through the system. It has hours to collect data. Then it is gone. It continues into the dark. It never stops. It never lands. It never sends humans. It is a reconnaissance mission. It tells us what is there. It does not let us live there. It is a step, a crucial step. But it is not the journey. It is the scout. The human journey requires stopping. It requires mass. You cannot put a human on a gram-scale probe. You cannot put a life support system on a sail. You need a ship. A ship needs mass. A ship needs braking. Can you use a laser to brake? Yes, but you need a laser at the destination. You need to build infrastructure at Alpha Centauri before you arrive. How? You send the sails first. They carry the seeds of the infrastructure. They 3D print the receivers. They build the lasers. Then the ships come. This is a multi-stage mission. It spans centuries. It requires coordination across time. The light sail concept is seductive because it uses the universe's own physics. It uses the speed of light. It minimizes the payload. It maximizes the speed. But it is fragile. It is dependent on Earth. If the laser array fails, the mission fails. If the sail tears, the mission fails. It is a high-risk, high-reward strategy. It is not robust. It is not forgiving. Interstellar space is unforgiving. A micrometeoroid hit could puncture the sail. A charge buildup could arc and destroy the electronics. The environment is hostile. The sail must survive the launch, the acceleration, the cruise, the arrival. It must survive decades of radiation. It must survive the thermal shock of the laser. It is a miracle of engineering. But imagine the sight: a ship riding a beam of light, leaving the solar system, accelerating silently. No fire, no smoke, just light. It is poetic. It is clean. It represents a maturity of technology. We are not burning things. We are directing energy. We are mastering the photon. This is the future of propulsion. Even if Starshot fails, the principle remains. Light drives are the way. Whether it is lasers or sunlight, the momentum of photons is the key to escaping the gravity well of the rocket equation. It is the way to the stars. It is the way to make the impossible possible. We are learning to ride the light. We are learning to surf the electromagnetic spectrum. And when we master it, the distance shrinks. The 4 light years become manageable. The journey becomes real. Chapter 5: The Arc of Flesh. Propulsion is only half the story. The ship is only the vehicle. The payload is the life. If we send machines, the problems are technical. If we send humans, the problems are biological. The human body is not designed for space. It is designed for Earth. 1G, 1 atmosphere, a magnetic field, a day-night cycle, a biosphere. Remove any of these and the body degrades. In microgravity, bones dissolve, muscles atrophy, the heart shrinks, the eyes change shape, vision blurs, the immune system weakens, radiation damages cells, cancer risks skyrocket, psychological stress increases, isolation causes depression, conflict arises in closed groups. These are the problems of a trip to Mars. A trip to Alpha Centauri is orders of magnitude harder. It is not months. It is decades. It is generations. We cannot keep people in microgravity for decades. They would not survive. They would not be able to walk when they arrived. They would be invalids. We need artificial gravity. We need rotation. A spinning ship, a centrifuge. This creates centrifugal force. It mimics gravity, but rotation brings its own problems. Coriolis effects, dizziness, nausea. The ship must be large to minimize the effect. 1 kilometer in diameter. This adds mass. It adds structural complexity. It must spin steadily for years. Bearings wear out. Motors fail. The balance must be perfect. If the mass shifts, the ship wobbles. It could tear itself apart. The engineering of a rotating habitat is a challenge in itself, but it is necessary. We need gravity to stay human. Then there is the life support, air, water, food. You cannot carry enough for decades. You must recycle everything, every breath, every drop of urine, every gram of waste. The ISS recycles water. It is not perfect. It loses mass. Over years, the losses add up. You need a closed loop, a biosphere, plants, algae, bacteria. They convert waste to food. They convert CO2 to oxygen, but ecosystems are unstable. They crash, pests invade, diseases spread. A fungus could wipe out the crop. A bacteria could clog the filters. The crew must be farmers. They must be engineers. They must be doctors. They must maintain the machine that keeps them alive. The ship is not just a vehicle. It is an ecosystem. It is a world. And worlds are hard to manage. The psychology is the silent killer. Imagine being locked in a tube for 40 years. You cannot go outside. You cannot feel the wind. You cannot see the sky. You see the same faces. You eat the same food. You hear the same hum of the engines. The Earth is a dot. It disappears. You are alone in the universe. The mission control is gone. The people you knew are dead. You are living for a goal you will not see. This is existential dread. It is a weight that crushes the mind. Crew selection is critical. You need people who are stable, who are resilient, who can handle isolation. But humans are social. We need variety. We need connection. A generation ship needs a society. It needs culture. It needs laws. It needs purpose. Who leads? How are decisions made? What happens if someone commits a crime? There is no police. There is no prison. There is only the ship. And then there is the generation gap. The people who launch the ship will not arrive. The people who arrive will not remember Earth. They will be born in space. They will know nothing else. To them, the ship is the universe. The destination is a myth, a story told by the elders. They might not want to go. They might want to turn back, but they cannot. They are committed. This creates tension between the generations, between the mission and the people. The original goal might be lost. The religion might change. The language might drift. By the time they arrive, they might not be the same species. They might not be human in the way we understand. They might be adapted to the ship, to the low gravity, to the radiation. They might be a new branch of humanity. This is the ark of flesh. It is a vessel of biology. It is fragile. It is complex. It is unpredictable. Machines can be repaired. Humans cannot. When a human dies, they are gone. Knowledge is lost. Skills are lost. The crew must train their successors. They must educate the children. They must pass down the technical knowledge. How to fix the engine. How to grow the food. How to navigate. If the chain breaks, the mission fails. The school is as important as the engine. The library is as important as the fuel. The culture is the software that runs the hardware. And software can corrupt. It can bug. It can crash. The social engineering is as hard as the physical engineering. We must also consider the ethics of birth. Should people be born on the ship? They did not choose this. They are conscripted by their parents. They are born into a cage. Is it right to bring life into a world without freedom? Without a planet? Without a sky? This is a moral question. It has no easy answer. But if we do not allow birth, the crew ages. They die. The ship arrives empty. We must allow birth. We must accept the responsibility. We must make the ship a home. Not just a transport. A home. This changes the design. It needs parks. It needs schools. It needs spaces for play. It needs beauty. It cannot be just functional. It must be livable. It must be humane. Because if it is not, the people will break. And if the people break, the mission breaks. The ark of flesh is the hardest path. It is the most expensive. It is the most risky, but it is the only way to move humanity. Machines can scout, machines can build, but humans must live. Humans must experience. Humans must be there. The journey changes us. It transforms us. We leave as earthlings. We arrive as starfarers. The distance is not just physical, it is evolutionary. We are evolving into a species that can live in the void. The ship is the womb. The journey is the gestation. The arrival is the birth. It is a painful process. It is a dangerous process, but it is necessary. We cannot stay in the cradle. We must grow up. We must leave. The ark of flesh is our vessel. It is our hope. It is our future, and it is waiting to be built. Chapter 6, The Sleep of Ages. The human body is a clock. It ticks. It counts down. Every cell division shortens the telomeres. Every heartbeat wears the valve. Every breath oxidizes the tissue. We are biological machines designed for a specific lifespan, calibrated for a specific planet, optimized for a specific gravity. Put us in a ship for 40 years, and the clock runs out. We age. We die. The mission outlasts the crew. This is the biological barrier. It is as rigid as the speed of light. You cannot travel to the stars if you rot before you arrive. You cannot colonize a new world if you are too old to walk upon it. The journey to Alpha Centauri requires a suspension of time. It requires us to cheat the clock. It requires the sleep of ages. This is the concept of hibernation, torpor, cryogenics, suspended animation. In science fiction, it is a plot device. A button is pressed, the pod closes, the hero wakes up unchanged. In reality, it is a nightmare of biology. We do not know how to freeze a human being and bring them back. Ice crystals form in the cells. They puncture the membranes. They shred the DNA. When you thaw, you are not a person. You are a slurry of broken tissue. We can freeze embryos. We can freeze sperm. We can freeze small samples of tissue. But a whole human? A conscious, breathing, thinking human? It is beyond our current capability. It is the holy grail of space medicine. And for the journey to Alpha Centauri, it is not optional. It is mandatory. Consider the resources. A awake crew consumes oxygen. They consume water. They consume food. They produce waste. They require space. They require psychological support. They require entertainment. They require light. They require gravity. The mass of life support for a 40-year mission is staggering. It is tons of supplies, tons of machinery, tons of redundancy. If you put the crew to sleep, the consumption drops to near zero. The metabolic rate slows. The heart beats once a minute. The breathing stops. The brain activity diminishes. They become cargo, inanimate objects that happen to be alive. The ship does not need a cafeteria. It does not need a gym. It does not need a park. It needs a freezer. It needs a monitor. The mass savings are enormous. The complexity drops. The risk of psychological breakdown vanishes. You cannot go mad if you are not conscious. You cannot fight if you are asleep. Hibernation solves the sociology problem. It solves the logistics problem. It solves the aging problem. But how do we achieve it? There are two paths, chemical and thermal. Chemical torpor involves inducing a coma. Drugs that slow the metabolism. Hydrogen sulfide, opioids, hypothermic agents. We do this in medicine today. Therapeutic hypothermia. We cool heart attack victims to protect the brain. We put patients in medically induced comas to let them heal. But we do it for days, not decades. The long-term effects are unknown. The body needs maintenance. Muscles need stimulation. Bones need load. If you lie still for years, you become bone dust. You become muscle fiber. You wake up unable to move. You wake up unable to breathe. The ventilator must breathe for you. The machine must pump your blood. You are not sleeping, you are life-supported. This adds complexity. The machine must not fail. If the ventilator stops, you die. If the heater fails, you freeze. If the drug pump clogs, you wake up in pain. The reliability must be absolute. Thermal cryogenics is the deeper sleep, freezing the body. Vitrification, turning the tissues into glass instead of ice. This requires cryoprotectants, chemicals that replace the water in the cells. They prevent crystallization. They are toxic. To vitrify a human, you must replace their blood with antifreeze. You must cool them to minus 100 degrees Celsius. You must store them in liquid nitrogen. This is current technology for organs. For humans, it is speculative. The revival is the hard part. How do you warm a body evenly? If you warm it too fast, it cracks. If you warm it too slow, ice forms. You need nanotechnology. Robots in the blood, repairing the cells as they thaw, fixing the DNA damage, restarting the heart. This is future tech. It is not ready. But for a mission launching in 50 years, it might be. The development curve is steep. We are learning to freeze life. We are learning to pause death. The ethics of hibernation are profound. If you freeze a person, are they dead? Legally, yes. Clinically, yes. But biologically, they are potential. They are waiting. If the ship crashes, they die in their sleep. They do not know. Is this mercy, or is it a violation? Do they consent to being turned off? What if they wake up wrong? What if the revival process damages the mind? What if they lose memories? What if they lose their personality? You arrive at Alpha Centauri, but you are not you. You are a copy, a reconstruction. This is the ship of Theseus problem applied to biology. If every cell is repaired, are you the same person? The crew might not be the people who left. They might be new entities born from the old. This changes the mission. It changes the lineage. There is also the risk of waking up early. What if the system malfunctions? What if you wake up in year 10? Alone, in the dark, miles from anywhere. No way to communicate. No way to go back. Just you and the hum of the ship. This is a horror scenario. The isolation would drive you insane before you died. The systems must have safeguards, redundancies. You cannot wake up unless the destination is reached. You cannot wake up unless the ship is safe. The lock must be unbreakable. But who holds the key? The computer? The computer can fail. The people on Earth, they will be dead. The key must be the destination itself. The ship must know when it is there. It must know when to wake the dead. This requires artificial intelligence. It requires autonomy. The ship must be the guardian of the sleepers. It must be the parent. It must be the god. Imagine the waking moment. The alarms sound. The heaters engage. The gas floods the chamber. The heart restarts. The eyes open. It is not like waking from a night's sleep. It is like being born. Again, the body is weak. The mind is foggy. The memories are distant. The first thing they see is not Earth. It is Alpha Centauri. Through the viewport, a new sun, new stars. They have skipped 40 years. Their friends are gone. Their families are gone. Their culture is gone. They are refugees from the past, arriving in the future. The psychological shock is immense. They need rehabilitation. They need therapy. They need time to adjust. But they cannot take time. They have work to do. The ship is landing. The colony must be built. They must switch from sleeper to worker instantly. This is a demand no human has ever faced: to die and be born again in the span of a week, to leave one world and inherit another. The sleep of ages is a gamble. It is a bet against biology. It is a bet against time. If it works, it unlocks the stars. It makes the journey possible. It makes the crew viable. It makes the mission humane. If it fails, it is a tomb, a coffin drifting in the dark, full of frozen dreams. We are developing the technology. Research is ongoing. Space agencies are studying torpor for Mars missions. It is the stepping stone. If we can sleep for 6 months, we can sleep for 6 years. If we can sleep for 6 years, we can sleep for 60. The progression is logical. The barrier is biological. But biology is not law. It is engineering. It is chemistry. It can be hacked. We are hacking the sleep. We are rewriting the code of life. We are teaching the body to wait. And when we master this, the distance shrinks. The 40 years become a blink. The journey becomes a nap. And we wake up at the destination, ready to begin. Chapter 7: The Mind in the Machine. There is another way to solve the human problem. Do not send the human, send the mind. Upload the consciousness. Transfer the data. This is the concept of digital immortality. It is the ultimate reduction of mass. A human body weighs 80 kilograms. A human mind, encoded as data, weighs bytes, kilobytes, megabytes, maybe gigabytes. The difference is exponential. You can send millions of minds for the cost of one body. You can send them at the speed of light. Laser communication. Data streams. You do not need a ship. You need a receiver. You build the receiver at Alpha Centauri. You send the software. The software downloads into a body, a synthetic body, a robot, a clone. You wake up in a new form. You are there, instantly, or nearly instantly. The travel time is the transmission time, 4 years, plus the processing time. This bypasses the biology, it bypasses the aging, it bypasses the life support. It is the cleanest solution. But it requires a theory of mind that we do not have. We do not know what consciousness is. Is it data? Is it pattern? Is it something more? Can you copy it? If you copy it, is the copy you? Or is it a twin? What happens to the original? If you upload yourself and die, did you travel? Or did you die and a clone woke up at Alpha Centauri thinking it was you? This is the teleportation paradox. It is a philosophical nightmare. But for the mission, it might not matter. The mission continues. The knowledge is there. The experience is there. The humanity is there, even if it is digital, even if it is simulated. The colony is established. The presence is real. The distinction between biological and digital life blurs. In the void, survival is the only metric. If the mind survives, the mission succeeds. The technology required is staggering. Brain-computer interfaces, neural mapping, whole brain emulation. We are beginning to map connectomes, the wiring of the brain, the synapses, the weights. It is complex, trillions of connections. But it is finite, it is physical, it can be scanned, it can be modeled. Moore's law applies. Computing power increases, storage density increases. In 50 years, scanning a brain might be routine. In 100 years, uploading might be possible. For an interstellar mission, the timeline fits. We launch the probes. They arrive. They build the infrastructure. They print the bodies. Then we send the minds. The hardware waits for the software. The body waits for the soul. The synthetic bodies must be robust. They cannot be flesh. Flesh rots. Flesh needs air. Synthetic bodies can be metal, ceramic, polymer. They can withstand radiation. They can withstand vacuum. They can be repaired. They can be upgraded. You can change your hand for a tool. You can change your eyes for sensors. You can adapt to the environment. This is transhumanism. It is the evolution of the species. We leave the biology behind. We become something else, something better suited for the stars. This is a terrifying thought for some. It is the loss of humanity. But what is humanity? Is it the meat or is the mind? If the mind remains, the humanity remains. The vessel is irrelevant. The journey changes us. It demands we change. We cannot go to the stars as apes. We must go as gods, digital gods. The risks are unique. Hacking, corruption, viruses. A digital mind can be infected. It can be altered. It can be deleted. The security must be absolute. The encryption must be unbreakable. The backup must be redundant. You cannot lose the crew. You cannot lose the history. The data must be protected. Also, the latency. Even at light speed, there is a delay. 4 years to send a message, 4 years to get a reply. So, digital minds at Alpha Centauri will be isolated. They will develop their own culture, their own laws, their own goals. They might diverge from Earth. They might become independent. They might not want to report back. They might become a new civilization. This is the risk of seeding intelligence. You lose control. You create children who grow up and leave. This is inevitable. It is the purpose of colonization, to create independence. But the transition is dangerous. The handshake between Earth and Alpha Centauri might break. The link might sever. The family might split. There is also the question of rights. Do digital minds have rights? Can they be turned off? Can they be copied? If you copy a mind, is it murder to delete the original? These are legal questions we must answer before we launch. We cannot send slaves. We cannot send prisoners. We must send volunteers, citizens, partners. The colony must be a democracy, even if it is digital. The governance must be established. The Constitution must be written. The code is the law, and the code must be just. This is social engineering at the highest level. We are building a society from scratch, in a vacuum, on a server. It is a new kind of nation, a nation of minds, a nation of light. The energy cost is low. A server farm uses power, but less than a life support system. Solar panels at Alpha Centauri can power the minds. The synthetic bodies can charge. The maintenance is minimal. The longevity is high. A digital mind can live forever, as long as the power runs, as long as the hardware holds. This offers a permanence that biology cannot. The colony can last for millions of years. It can outlive the star. It can migrate to other systems. It can spread. This is the ultimate legacy, not genes, but memes, information, culture, knowledge. We spread the mind of humanity across the galaxy. We become a network, a web of consciousness, connected by light, separated by distance, but united by origin. This is the future. It is inevitable. The journey to Alpha Centauri is the first step, the first upload, the first transmission, the first digital birth. Chapter 8, the arrival. The journey is long, but the arrival is critical. It is the moment of truth, the moment of maximum risk. You have traveled for decades. You have survived the void. You have kept the crew alive, or the data intact. Now you must stop. You must enter the system. You must slow down. This is the deceleration problem. We discussed it before. It is the mirror of the launch. You need energy to stop. If you used a laser to accelerate, you need a laser to brake. But there is no laser at Alpha Centauri, unless you sent one. This requires a precursor mission. Send the brake first. Send the infrastructure. Send the magnetic sail. Send the fuel depot. This complicates the architecture. It requires coordination. It requires timing. If the brake is not ready, you fly past. You miss. You fail. Imagine the ship approaching the system. The stars shift. The parallax changes. Alpha Centauri A and B grow bright. Proxima flares in the distance. The ship is moving at 20% of light speed. Relative velocity is high. Impact with a dust grain is catastrophic. The shield must hold. The forward armor must absorb the kinetic energy. The heat must be dissipated. The ship glows red, white. It is a meteor entering an atmosphere, but the atmosphere is vacuum. The interstellar medium is the friction. The ship erodes, layer by layer. It must be thick enough to survive, but not too thick to accelerate. The balance is precise. The engineering is tight. Then the braking maneuver. The magnetic sail deploys. A loop of superconducting wire, kilometers wide. It creates a field. It interacts with the interstellar medium. It interacts with the stellar wind. It creates drag. It slows the ship. It is a parachute made of CI Chung. It is invisible. It is powerful. But it takes time. You cannot stop instantly. You must begin braking years in advance. You must calculate the trajectory perfectly. If you brake too early, you stop too far out. If you brake too late, you fly through. The navigation must be autonomous. Earth cannot help. The signal takes 4 years. By the time Earth knows you missed, you are gone. The ship must decide. The computer must choose. It must adjust the sail. It must tweak the angle. It must manage the heat. It is a dance with gravity, a ballet of physics. If you are a biological crew, you wake up during this phase. You feel the deceleration. The G-forces build. 1 G, 2 Gs. It presses you into the couch. It feels like weight. It feels like home. But it is stress. The body must handle it. The heart must pump against it. The blood must flow. If the force is too high, you black out. If it is too low, you take too long. The profile must be optimized. The crew must be trained. They must be ready. They wake up from the sleep. They suit up. They check the systems. They prepare for landing. The tension is palpable. They are the first humans to leave the solar system. The weight of history is on them. Every move is watched. Every breath is recorded. They are the representatives of Earth. They must not fail. If you are a digital mind, the arrival is different. You download into the receiver. You boot up. You check the sensors. You see the world through cameras. You feel the ground through pressure plates. You're embodied, but you are new. The calibration takes time. You must unlearn the gravity. It is different from Earth. Proxima B might be heavier or lighter. Your movements must adjust. Your balance must reset. You stumble. You fall. You learn. It is like being a child. Again, the learning curve is steep, but you are fast. You can process data quickly. You can adapt. You can share knowledge instantly. The crew learns together. They upload skills. One learns to walk. All know how to walk. One learns the terrain. All know the map. The collective intelligence is powerful. They are a hive, but they are individuals. They coordinate perfectly. They begin the work. The environment is hostile. The radiation is high. The temperature is extreme. The atmosphere might be toxic. The first task is shelter. Build a base, pressurize it, shield it, create a safe zone. This requires resources, mining, processing, manufacturing. You cannot bring everything. You must use what is there. In situ resource utilization, ice for water, regolith for bricks, metals for structure. The machines must work. The robots must dig. The printers must build. It is an industrial operation in an alien world with no supply chain. If a part breaks, you must make a new one. If a tool fails, you must fix it. The self-sufficiency must be total. There is no Amazon. There is no FedEx. There is only what you make. This is the ultimate test of engineering. Can we build a civilization from scratch, with nothing, on a world that does not want us? The arrival is not the end. It is the beginning. The journey was the gestation. The arrival is the birth. The colony is the child. It is vulnerable. It is small. It is fragile. A storm could destroy it. A flare could kill it. A disease could wipe it out. The first years are critical. The survival rate is low. Most colonies fail. History tells us this. On Earth, colonies failed, starved, froze, fought. The same will happen here. The first group might not survive. The second group might. The third might establish. It is a process of attrition. We must send enough. We must send redundancy. We must accept loss. This is hard. We value life. We do not want to send people to die. But the stars demand sacrifice. The arrival is the payment. We pay with risk. We pay with lives. We pay with hope. And if we succeed, the payment is worth it. The foothold is gained. The door is open. The future is secure. Chapter 9, the first steps. The airlock cycles. The pressure equalizes. The light turns green. The door opens. This is the moment. The first step. Not on the moon. Not on Mars, on another star. The boot touches the soil. The dust puffs. It is red, or gray, or black. It does not matter. It is ground. Solid ground. Outside the solar system, the astronaut looks up. The sky is different. The sun is different. Alpha Centauri A is bright, yellow, like home. But there is another sun. Alpha Centauri B, orange, dimmer. They dance in the sky, sometimes close, sometimes far. The shadows are complex, double shadows, triple shadows. It is disorienting. It is beautiful. It is alien. The feeling is indescribable. It is not just exploration. It is expansion. It is evolution. The species has grown. It has left the nest. It has taken flight. The astronaut feels small, but also huge. They represent billions. They represent history. They represent the future. They take a sample. They plant a flag. Maybe not a flag, a marker, a beacon, a message. We were here. We are here. We will be here. The message is for us and for whoever comes next. Maybe aliens. Maybe our descendants. Maybe machines. The marker lasts. The footprints fade, but the presence remains. The work begins immediately. Science, survey, map the terrain, find the water, find the resources, find the dangers, the radiation levels, the seismic activity, the weather patterns. Proxima is active. Flares are common. The crew must monitor the space weather. They must seek shelter when the star erupts. They live in caves, or underground, or under meters of regolith. They are troglodytes, but high-tech troglodytes. They have lasers. They have computers. They have fusion reactors. They are safe, but they are confined. They do not walk on the surface often. They wear suits. They are careful. The environment is not friendly. It is not Earth. It is a new world. It must be tamed. The biology is the next step. Can we grow plants? The soil might be toxic, perchlorates. Heavy metals, it must be cleaned, it must be enriched. Bacteria, fungi, worms, the ecosystem must be built. From the bottom up, it takes years, decades. The first greenhouse is small, a few potatoes, some lettuce. It is a victory. Fresh food, real food. Not paste, not pills. The taste of a tomato grown on another star. It is sacred. It is life. The plants grow. They produce oxygen. They recycle waste. The loop closes. The colony breathes. It is alive. It is self-sustaining. This is the turning point. When the colony can survive without supplies from Earth. When it can grow. When it can expand. This is independence. This is maturity. The society forms. Rules. Roles. Routines. People are born. Children of the stars. They know no other home. They are adapted. Their bones are denser. Their lungs are different. They are a new subspecies, Homo stellaris. They look at Earth as a myth, a story, a legend. They feel no connection. Their loyalty is to the colony, to the ship, to the system. This is natural. Distance creates divergence. Culture evolves. Language changes. New words for new things. New concepts for new realities. They are not us. They are them. And that is okay. That is the point. We sent them to be different. To survive where we cannot. To live where we cannot. They are the adaptation. They are the future. The first steps are clumsy, but they are permanent. They mark the boundary, the edge of the human sphere. We are no longer a single planet species. We are multistellar. This changes everything. It changes our philosophy. It changes our religion. It changes our politics. We are not alone. Even if we are the only life, we are in two places. We are distributed. We are resilient. An asteroid can kill Earth. It cannot kill Alpha Centauri. The backup is active. The species is safe. This is the insurance. This is the legacy. The first steps are small, but the impact is galactic. They echo. They resonate. They tell the universe that we are here, that we are coming, that we will not stop. Chapter 10. The new home time passes. Decades, centuries. The colony grows. It becomes a city. It becomes a nation. The ships stop coming, or they come less often. The link with Earth weakens. The light lag is too long. The culture drifts. They develop their own identity. They build their own monuments. They write their own history. They forget the journey. They remember the arrival. The journey is prehistory. The arrival is the beginning. They celebrate landing day. They honor the sleepers, the first walkers, the founders. They are saints. They are heroes. Their names are on the streets. Their faces are on the walls. They are the mythology. The technology advances. They improve the terraforming. They warm the planet. They thicken the atmosphere. They melt the ice. They create oceans. It takes millennia, but they are patient. They have time. They are not rushing. They are building. They are gardening. They are shaping the world. It becomes habitable, Earth-like, but not Earth. It is Alpha. It is unique. It has its own beauty, its own dangers, its own rhythm. The people adapt. They change. They become part of the landscape. They are not visitors. They are natives. They belong. The relationship with Earth is complex, sometimes close, sometimes distant. Trade is impossible. The cost is too high. Communication is the only link. Data, knowledge, art, music, stories, they share culture, but it is delayed. By the time Earth hears a song, the singer is dead. By the time Earth sends a reply, the listener is dead. It is a conversation between ghosts. It is poetic, it is sad, but it is connection. They know they are not alone. They know they have family. even if they never meet. The bond is genetic. It is historical. It is unbreakable. Even if they separate, even if they diverge, they are branches of the same tree. The new home is not just a place. It is a state of mind. It is security. It is hope. It is proof. Proof that we can leave. Proof that we can survive. Proof that we can grow. It inspires Earth. It inspires other colonies. Mars, the Moon, the outer planets, the network expands. The human sphere grows. We become a civilization, a galactic civilization. It starts with one step, one ship, one colony. Alpha Centauri is the seed. It is the first. It is the model. It shows the way. It proves it is possible. It removes the doubt. It removes the fear. It opens the gate. The challenges remain. Resources are finite. Politics are messy. Conflict is possible. War could happen. Between colonies, between Earth and Alpha, the distance protects them, but also isolates them. They must manage their own peace. They must create their own order. They must learn from our mistakes. They must be better. They have the advantage of hindsight. They know what happened on Earth. They know the risks. They can avoid them. They can build a better society, a fairer society, a more stable society. This is the hope, that the stars will refine us, that the void will purify us, that the journey will make us worthy. The new home is a promise to the future, a promise to the children, a promise to the universe. We are here, we are staying, we are growing, we are life, and life finds a way. It adapts, it evolves, it spreads. Alpha Centauri is the proof. It is the beacon. It is the light in the dark. It says come. It says live. It says begin. And we do. We begin again and again and again until the galaxy is full, until the silence is broken, until the universe knows we exist. This is the destiny. This is the path. This is the new home. Chapter 11. The message. Home. The colony is established. The people are safe. The future is secure. But there is one last task. The message, the report, the letter home. It takes 4 years to arrive. It takes 4 years to get a reply. It is a slow conversation, but it is vital. It connects the branches. It shares the knowledge. It shares the experience. It says, we made it. It says, thank you. It says, we are okay. This message is the closure of the journey. It is the completion of the loop. The Earth sent the ship. The ship sends the word. The circle is closed. The message is not just data. It is emotion. It is hope. It is love. It is from the children to the parents, from the future to the past. It says, your sacrifice was worth it. It says, your dream came true. It says, we are living the life you imagined. This is powerful. It validates the struggle. It validates the cost. It validates the risk. The people on Earth who funded the mission, who built the ship, who died waiting, they are honored. Their work is remembered. Their legacy is alive. The message is the monument. It is the statue. It is the plaque. It is written in light, sent across the void. The content of the message is rich. Science, discovery, images, videos, songs, stories. They show the new world. They show the new life. They show the new people. They show the beauty. They show the struggle. They show the truth. It is not propaganda. It is reality. It is raw. It is honest. It helps Earth understand. It helps Earth learn. It helps Earth prepare. For the next mission, for the next step. The knowledge flows both ways. Earth sends updates, technology, culture, news. The colony stays connected. They stay human. They stay part of the whole. But eventually, the message stops or changes. The colony becomes independent. They do not need Earth. They do not need the approval. They send messages less often. They become a separate voice, a separate song. The harmony remains, but the unison breaks. They sing their own tune. This is natural. This is growth. The child leaves the parent. The student surpasses the teacher. The colony exceeds the origin. This is the goal. This is the success. If they remained dependent, the mission failed. If they become independent, the mission succeeded. The message home becomes a greeting, not a report, a hello, not a help. We are fine. You are fine. We are both here. We are both alive. The message is a time capsule for the future, for the archaeologists, for the aliens. It says humanity was here. It says we tried. It says we loved. It is a record of existence. It is a proof of life. It will travel forever, even if Earth dies, even if Alpha dies. The light travels, the message persists. It is immortal. It is the soul of the species, cast into the dark, hoping to be heard, hoping to be understood, hoping to be remembered. This is the ultimate purpose, to be known, to be seen, to be heard. The message home is the voice of humanity, singing in the night, singing to the stars, singing to itself. Chapter 12. The Great Silence. As we approach the destination, as the ship cuts through the interstellar medium and the stars shift their positions in the sky, we must confront a question that has haunted astronomers for decades. It is a question that echoes in the quiet moments of the journey, when the engines are humming and the crew is sleeping, or when the digital minds are processing data in the deep, cold. It is the question of the great silence. Where is everybody? We are traveling 4 light years to the nearest star, but the galaxy is 100,000 light years across. It contains hundreds of billions of stars. Many of them are older than our sun. Many of them have planets in habitable zones. Statistically, life should be common. Intelligence should be common. Civilizations should be everywhere. And yet, when we listen to the radio waves, when we scan the spectra of distant atmospheres, we hear nothing. We see nothing. The universe is dark, it is quiet, it is empty. This is the Fermi paradox. And the journey to Alpha Centauri is the first real test of it. For decades, we have speculated from the comfort of Earth. We have written equations. We have built models. We have argued about the great filter. The great filter is the idea that there is some barrier to life becoming interstellar, some step in the evolution of complexity that is incredibly difficult to pass. Maybe the origin of life is rare. Maybe the jump from single-celled to multi-celled is rare. Maybe intelligence is rare. Or maybe, and this is the terrifying option, maybe interstellar travel is impossible. Maybe every civilization reaches our stage, looks up at the stars, wants to go, and then fails. They run out of energy. They destroy themselves. They succumb to the distance. The distance kills them before they can leave. If we succeed, if we reach Alpha Centauri, we pass the filter. We prove that it is possible. We prove that the distance can be bridged. But what do we find when we arrive? This is the core of the mystery. Do we find ruins? Do we find probes? Do we find signals? Or do we find exactly what we expect? Rocks, ice, and vacuum? If we find nothing, the silence becomes louder. It implies that we are the first, or that we are the only ones. This is a heavy burden. To be the first consciousness to wake up in the galaxy. To be the only eyes looking out. It implies a responsibility. If we are the only ones, then the preservation of life is our duty. We are the universe experiencing itself. If we die, the light goes out. The journey to Alpha Centauri is not just about survival, it is about stewardship. We are carrying the flame of awareness into the dark. But consider the alternative. What if we find something? What if there are ruins on Proxima b? What if there are structures in the asteroid belt of Alpha Centauri A? This changes everything. It means the filter is behind us. It means others have made it. But where are they now? If they were here and they are gone, what happened to them? Did they leave? Did they die? Did they evolve into something we cannot recognize? Finding ruins would be a warning. It would tell us that civilizations rise and fall, that the stars do not guarantee immortality. It would tell us that the distance is not the only enemy. Time is the enemy. Entropy is the enemy. A civilization can conquer space and still be defeated by time. The ruins would be a tombstone. They would say, "We were here, we tried, we failed," and we would be the visitors at the grave. This possibility affects the mission planning. Do we prepare for contact? Do we bring weapons? Do we bring gifts? The protocols for first contact are theoretical. We have no practice. We have no rules. If we find a machine, do we touch it? If we find a signal, do we answer? The risk of contamination is high, biological contamination. We could bring Earth microbes to Alpha Centauri. We could destroy native life before we even know it exists. This is planetary protection. It is an ethical constraint. But if the life is microbial, does it matter? If the life is intelligent, does it matter? The power dynamic is skewed. We are the arrivals. We are the invaders. Even if we come in peace, our presence is disruptive. We bring our technology, our noise, our gravity. We change the system. We must be careful. We must be humble. We are guests in a house we did not build. The silence also affects the crew psychologically. Imagine traveling for 40 years to find nothing, just rocks. The disappointment would be crushing. The mission was sold on the possibility of life, of discovery, of connection. To find only geology is a letdown. It validates the isolation. It confirms that we are alone. This could lead to despair. The crew might question the purpose. Why leave Earth for a dead rock? But the purpose shifts. It becomes about us, about humanity, not about them. Because there are no them, there is only us. The colony becomes more important. The survival of the species becomes the only goal. The discovery of emptiness is still a discovery. It tells us where we stand. It tells us the value of what we have. Earth becomes more precious. Life becomes more precious. Because it is rare, because it is fragile. The silence teaches us reverence. There is also the possibility of the zoo hypothesis. Maybe they are there. Maybe they are watching us. Maybe they have a quarantine. Maybe they are waiting for us to reach a certain level of maturity before they reveal themselves. Alpha Centauri could be the checkpoint. If we arrive and behave well, if we show wisdom, if we show peace, then they step out of the shadows. If we arrive with weapons, if we act with aggression, they remain hidden, or they intervene. This is speculative. It is science fiction, but in the context of the journey, it is a variable. We must act as if we are being watched, because we might be. The universe might be full of life that is simply quiet, listening, waiting. Our journey is an announcement. We are saying, we are here, we are coming, we are ready. The silence might break when we arrive. The radio waves might light up. The first message might not be from Earth. It might be from Alpha. Welcome. We have been waiting. This changes the narrative of the journey. It is not an exploration. It is an audition. We are proving ourselves, proving that we are worthy of the stars, proving that we can handle the technology, proving that we can handle the power. The distance is the test, the journey is the exam, and the arrival is the grade. If we pass, we join the community. If we fail, we are left alone, or we are removed. The stakes are higher than survival. They are about status, about membership in the cosmic club. This is a profound thought, that we are not just exploring space, we are trying to gain entry, that the universe has a door, and Alpha Centauri is the doorbell. We are ringing it, we are waiting for an answer. And the wait is 4 years. Every second of that wait is filled with anticipation, with fear, with hope. The silence is not empty. It is pregnant with possibility. It is holding its breath. And so are we. Chapter 13, The Psychology of Exile. We have spoken of the physics. We have spoken of the biology. But we must speak of the mind. The human mind is not built for exile. It is built for connection, for community, for the familiar. To leave Earth is to sever the umbilical cord of the species. It is to cut the tie that binds us to our origin. This is a traumatic event. It is a psychological rupture. The crew of the interstellar ship are not just travelers. They are exiles. They are refugees. They are leaving the only home they have ever known for a home they have never seen. This requires a mental restructuring, a rewiring of the psyche. They must learn to love the ship. They must learn to love the void. They must learn to love the destination more than the origin. This is not natural. It is engineered. Consider the moment of departure. The ship leaves the solar system. The Earth becomes a dot, then a star, then it disappears into the glare of the sun. This is the final goodbye. There is no return ticket. There is no rescue mission. If the ship breaks, they die. If the colony fails, they die. They are on their own. This knowledge creates a specific type of stress. It is not the stress of danger. It is the stress of finality. There is no backup. There is no plan B. This can lead to paralysis, or it can lead to focus. The crew must be selected for this. They must be resilient. They must be able to compartmentalize the grief. They cannot mourn Earth every day. They must accept the loss. They must bury the past. They must live in the present. The ship is the present. The mission is the present. Earth is the past, and the past is dead. This creates a cult-like dynamic. The mission becomes a religion. The goal becomes a deity. The commanders become priests. The rules become dogma. This is necessary for survival. In a closed system, dissent is dangerous. Conflict is dangerous. Unity is survival. The crew must believe. They must believe in the mission more than they believe in themselves. They must sacrifice their individuality for the collective. This is a loss of freedom, but it is the price of the journey. They are not free individuals. They are cells in a larger organism. The ship is the body. They are the organs. Each has a function. Each must perform. If one fails, the body suffers. This is a heavy burden. It suppresses the human spirit. It suppresses creativity. It suppresses emotion, but it keeps them alive. It is a trade-off. Safety for freedom. Survival for expression. And then there is the earth sickness. A longing for the planet. For the sky. For the wind. For the rain. These are sensory memories. They fade over time. The crew forgets what grass smells like. They forget what rain sounds like. They forget what true darkness looks like. The ship is artificial. The light is electric. The air is recycled. The sound is mechanical. Over decades, this becomes normal. Earth becomes the dream. The memory becomes distorted. They romanticize the past. They remember Earth as a paradise. When they arrive at Alpha Centauri, the reality might not match the memory. The new world might be harsh. It might be ugly. It might be dangerous. The disappointment could be severe. They might feel cheated. They might feel betrayed. They left paradise for a wasteland. This is a risk. The psychological preparation must include reality training. They must know what to expect. They must not dream. They must know the truth. The truth is hard, but it is better than a lie. The generational aspect is even more complex. The children born on the ship do not have earth sickness. They do not miss what they never had. To them, the ship is normal. The void is normal. Earth is a story, a myth, a legend. They might not care about the mission. They might not care about colonization. They might want to stay on the ship. They might view the planet as hostile. This creates conflict between the generations. The elders want to land. The youth want to stay. The elders remember Earth. The youth know only the ship. This is a cultural divide. It is a conflict of identity. Who owns the mission? The ones who launched it, or the ones who live it? The ones who paid the cost, or the ones who reap the reward? This must be resolved. There must be a transfer of purpose. The purpose must evolve. It must become the purpose of the children, not the parents. The children must choose the mission. They must own it. If they are forced, they will rebel. If they choose, they will succeed. The isolation also affects the sense of self. In the void, there are no landmarks, no borders, no nations. There is only the ship. The crew becomes a tribe, a new ethnicity. They develop their own slang, their own customs, their own holidays. They celebrate launch day. They celebrate arrival day. They create new traditions. They separate themselves from humanity. They become starfarers. This is a psychological evolution. They are no longer earthlings. They are something else. This is necessary for the colony. If they remain earthlings, they will try to recreate Earth. And Earth cannot be recreated. The new world is different. They must adapt. They must become native. They must let go of the old identity. They must embrace the new one. This is a death and rebirth. The earthling dies. The starfarer is born. The journey is the metamorphosis. There is also the fear of the dark. The void is absolute. There is no up, no down, no horizon, just black. This can cause vertigo, disorientation, anxiety. The crew must learn to navigate by instruments, by stars, by data. They must trust the machines. They must trust the math. They must trust the invisible. This is a leap of faith. They are flying blind through the dark. They are trusting that the destination is there. They are trusting that the physics holds. They are trusting that they are not lost. This trust is the foundation of the mission. Without it, they would panic. They would turn back, but they cannot turn back. So they must trust. They must believe. The psychology of the journey is a psychology of faith. Faith in science, faith in each other, faith in the future. It is a secular religion, and it is the only thing that keeps them sane. Chapter 14, the speciation event. As the ship travels, as the generations pass, biology begins to diverge. Evolution is not just a process of millions of years. it can happen quickly. In a closed environment, with selective pressure, traits change. The crew on the ship are subject to different forces than the people on Earth. The gravity is artificial. It might be lower. 1 G is hard to maintain in a spinning ship. It might be 0.8 G or 0.5 G. The children born in this environment will develop differently. Their bones will be lighter, their muscles will be leaner, their hearts will be different. They will be adapted to the ship. When they arrive at Alpha Centauri, the gravity might be different again. Proxima b might be 1.2 G. Their bodies will struggle. They will be sick. They will be weak. They are not adapted to the destination. They are adapted to the journey. This creates a biological mismatch. The colonists are not suited for the planet. They are suited for the ship. This suggests that the colony might not live on the surface. They might live in orbit. They might live in stations. They might never touch the ground. They are space dwellers. This changes the mission profile. We are not colonizing a planet. We are colonizing a system. The habitat is the ship. The planet is the resource. They mine the planet. They do not live on it. This is a fundamental shift. We imagined people walking on alien soil, but the reality might be people living in bubbles above it. They are aquatic. They are amphibious. They are not terrestrial. They are celestial. This is a new niche, a new ecological role. Homo stellaris, the star human. The radiation also drives evolution. Interstellar space is full of cosmic rays. The ship's shielding is not perfect. Some radiation gets through. It causes mutations. Most are harmful. Some are neutral. Rarely, some are beneficial. Resistance to radiation. Better DNA repair. Faster healing. Over generations, these traits could become common. The crew becomes harder, more resistant, more robust. They are evolving to survive the void. They are becoming radiation-hardened humans. This is natural selection. The weak die. The strong survive. It is brutal. It is efficient. It is evolution in fast forward. The people on Earth are not undergoing this pressure. They are protected by the magnetosphere, by the atmosphere. They are soft. The starfarers are hard. The gap widens. They become different species. This speciation has ethical implications. Can they interbreed with Earthlings? Maybe not. The genetic drift might be too high. The children might be sterile. The line is broken. Humanity splits. There are Earth humans and star humans. They are cousins, but they are distinct. This could lead to prejudice, discrimination, conflict. The Earthlings might view the star humans as mutants, as monsters. The star humans might view the Earthlings as weak, as obsolete. This is the history of migration repeated, the old world versus the new world. But amplified by biology, it is not just culture, it is flesh, it is bone, it is gene. The distance creates biological barriers. The isolation creates genetic drift. The result is divergence. We are not one species anymore. We are a genus. The digital minds accelerate this. If the crew uploads, they are no longer biological. They are software. They can copy themselves. They can modify themselves. They can optimize their code. They can remove emotions. They can enhance intelligence. They can become post-human. They are not Homo sapiens. They are Homo digitalis. They are a new form of life, based on silicon, based on light. They do not age. They do not die. They do not reproduce biologically. They replicate digitally. This is a speciation event of a different order. It is not evolution. It is design. They are designing themselves. They are choosing their traits. They are becoming gods. This is the ultimate divergence. The biological, humans stay on Earth. The digital humans go to the stars. The split is complete. The family is broken. But the lineage continues in a new form. This raises the question of identity. Are the digital humans still human? They have human memories. They have human origins. But they do not have human bodies. They do not have human needs. They do not feel pain. They do not feel hunger. They feel data. They feel logic. Is this humanity, or is it something else? If we send them, are we sending ourselves? Or are we sending our children, our successors? This is the legacy question. Do we want to be remembered, or do we want to be surpassed? If the digital humans are better suited for the stars, then we should let them go. We should let them evolve. We should let them become. We should stay behind. We are the roots, they are the branches. The roots do not go to the sky. The branches do. This is the natural order. We accept our role. We accept our limit. We let them fly. The speciation event is inevitable. We cannot stop it. The environment demands it. The distance demands it. The physics demands it. We must adapt or die. The starfarers will adapt. They will change. They will become new. This is not a tragedy. It is a triumph. It is life doing what life does. It expands. It varies. It selects. It survives. We are witnessing the birth of a new branch of the tree of life, and we are the trunk. We hold them up. We feed them. We let them grow, and then they leave. They reach for the light. They become something else, and we are proud because they are ours, even if they are not us. They are our legacy. They are our future. They are the proof that we lived, that we mattered, that we started something. The speciation event is not the end of humanity. It is the expansion of humanity. It is the definition of life. Conclusion. We began with a look up, a look at the stars, a look at the distance. We end with a look forward, a look at the future, a look at the possibility. The journey to Alpha Centauri is impossible. By every measure, by every metric, by every law, it is too far. It is too hard. It is too expensive. It is too dangerous. And yet we will go. We must go. Because the impossible is just a challenge. It is a puzzle. It is a wall waiting to be climbed. We are climbers. We are explorers. We are seekers. We do not stop at the edge. We step off. We fly. We fall. And we learn to fly again. The terrifying distance is not a barrier. It is a bridge. It connects us to the rest of the universe. It connects us to our potential. It connects us to our destiny. The journey changes us. It makes us better. It makes us stronger. It makes us more. We leave as humans. We arrive as something else, something greater, something stellar. The cost is high. The risk is real. The pain is certain. But the reward is infinite. A future among the stars. A life without limits. Existence without end. The technologies we discussed, the nuclear engines, the light sails, the hibernation, the digital minds, they are not fantasies. They are plans. They are projects. They are waiting to be built. They are waiting for us. We have the knowledge. We have the capacity. We have the will. We only need the courage to try, the courage to fail, the courage to succeed. The journey to Alpha Centauri is the test. It is the exam. It is the final boss. And we are ready. We are preparing. We are building. The ships are being designed. The engines are being tested. The crews are being trained. The dream is becoming real. So look up again. Look at that point of light, Alpha Centauri. It is not just a star. It is a destination. It is a home. It is a future. It is waiting for us. It is calling us. Come, leave the cradle. Grow up, become. The distance is terrifying, but the view is worth it. The view of a new sun, a new world, a new life. The view of humanity spread across the galaxy, shining in the dark, alive, free, eternal. This is the impossible journey. And it is ours. It is waiting. The engines are ready. The sails are set. The sleepers are waiting. The minds are uploading. The time is now. The journey begins. Not tomorrow, not next year. Now, in our minds, in our hearts, in our will, we are going to Alpha Centauri, and nothing will stop us. Nothing can stop us. The stars are ours, and we are taking them, one step, one ship, one light year at a time, until the impossible is done, until the journey is complete, until we are home.